Hello everyone, welcome to Prevent Tutorials. This is Deepak, Mathematics. In the previous class we had discussed about how to compare two sets. So again I am going to recall you how to compare two sets. Sets can be compared only if their orders are equal. Otherwise it is not possible to compare any two sets. Okay. Today our topic is about arithmetic operations. Operations on sets. That means adding, subtracting, and multiplying and dividing. So first of all we'll discuss how to add two sets. Okay. Addition of two sets. I think I already expressed in the previous class how to add two sets. Addition of two sets is possible if they are having similar sets. That means if the sets are similar, then only it is possible for us to add or to subtract. For example, a square root of c plus b square root of c. So this is equal to a plus b square root of c. So like that, okay. I'll tell you an example. 7 square root of 5 plus 6 square root of 5. Both are the like sets. What do you mean by like sets? Possessing the same radicands and possessing the same order. Order should be equal and the radicand should be equal. Then only they can be called as like sets. So here addition of like sets. Actually we can add only like sets. We cannot add two unlike sets. So this is equal to 7. It means 7 5 roots plus 6 5 roots is equal to 7 plus 6 of root 5. 7 plus 6 is equal to 13 root 5. Totally 13 5s. Okay, just like 6 pence plus 5 pence is equal to 11 pence. In the same way, 7 5 roots plus 6 5 roots is equal to 13 5s. This can be explained easy way. 3x plus 2x. If the variables are equal and if the exponents are equal, then they are called as like terms. In the same way, if the radicands are equal and the orders are equal, then the sets can be called as like sets. Here we add 3x plus 2x. 3x plus 2x, total 5x. In the same way, 7 5 roots plus 6 5 roots is equal to total 13 5s. Okay. Similarly, 8 cube root of 13 plus 11 cube root of 13. 8 cube root 13s plus 11 cube root 13s. Total 8 plus 11. 8 plus 11 is equal to 19 cube root of 13s. There are 19 cube root of 13s. Just like what I said. Okay, in the same manner, 19 cube root of 13s. So 6 fifth root of 11 plus 8 fifth root of 11 plus 13 fifth root of 11, which is equal to 6 plus 8 plus 13 fifth root of 11s. Okay, 6 plus 8 is equal to 14. 14 plus 13 is equal to 27. 27 fifth root of 11s. Okay, so from this what you understood? Addition of sets is possible if the sets are similar sets. In the same manner, subtraction of sets. Subtraction of sets is possible if the sets are similar surds. Square root of 11 or 11 square root of 11 minus 3 square root of 11. That means I am subtracting 11 square root 11s and 3 square root 11s. So there are 11 square root 11s. From that I am taking away 3 square root 11s. So that becomes 11 minus 3 square root of 11s. So 11 minus 3 is 8. 8 square root of 11s. Okay, like that. So here what you understood? Addition and subtraction of 2 or more surds is possible if the radicands are equal and the orders are equal. For example, if I say cube root of 11 plus fifth root of 11, they are unlike surds. Here radicands are equal, but the orders are not equal. This is the surd of second order and this is the surd of fifth order. So it is not possible for us to add these two surds. Just like x plus y. What is the answer? That itself is the answer, x plus y. We can't add x and y. So many of you think that is x plus y is equal to xy. This is wrong. Similarly, they are unlike terms. Unlike terms cannot be added, cannot be subtracted. In the same way, unlike surds cannot be added, cannot be subtracted. Okay? So addition and subtraction of like surds. Again multiplication. Multiplication of unlike surds is possible, but provided their order should be equal. For example, root 3 and root 7. Root 3 and root 7 cannot be added, but they can be multiplied. Okay, they can be multiplied. Here radicands are not equal, but they can be multiplied, which is equal to square root of 3 into 7 is equal to square root of 7 3 is 21. Root 3 and root 7 can be multiplied because their orders are equal. So multiplication of two surds is possible if their orders are equal. Radicands may not be equal. Radicands may be equal, may not be equal, but order should be equal. So we can multiply two unlike surds, provided their orders should be equal. Okay, root 3 into cube root of 7. Is it possible? It is not possible. Here the orders are not equal, so it is not possible. If you want to multiply, you have to make the orders equal. Just like how we compare two surds. Okay, make this root 3 equal to cube root of something else, some non-zero number, and then you have to multiply. Just like how do you compare two surds? To compare two surds, first of all, it is very necessary that we should make their orders equal. In the same manner, if you want to multiply these two surds, you have to either make root 3 as cube root of some non-zero number or root 3. This is not possible, this is possible. Okay, so then you have to multiply. Similarly, division of two surds. Division of two surds. Root 15 by root 5. That is equal to root 15 by 5. 5 3s are 15, which is equal to root 3. So here also we can divide two unlike surds, provided their orders should be equal. Okay, cube root of 14 by cube root of 7, which is equal to cube root of 14 by 7. 7 2s are 14, which is equal to cube root of 2. So first of all, what we understood? Okay, we can understand that two or more surds adding is possible if their orders are equal and their radicands are equal. That means there should be a similar surds. And subtraction of two surds is possible if their orders are equal and radicands are equal. But whereas in multiplication, if the orders are equal and if the radicands are not equal, it is possible for us to multiply or to divide any two surds. That means unlike surds can be multiplied, can be divided, provided if their orders should be equal. But addition and subtraction of two or more surds is possible if their orders are equal and the radicands must be equal. Okay. So many of you will commit a mistake by doing like this. Okay. Simply they will add like this. Root 3 plus root 7 is equal to root 3 plus 7 is equal to root 10. This is absolutely wrong. I already told you root a plus root b is not equal to root a plus b. In the same manner, root a minus root b is not equal to root a minus b. Okay? So many of you will commit a mistake like this by simply adding the radicands. So that is absolutely wrong. Okay? We have to add the multiple of those two surds, but not the surds, and the radicands must be equal. Okay? So this is how you have to operate any two surds. Okay? Hope you understood. Okay? So finally once again we'll recall. So addition of two surds is possible, okay, only for the similar surds. Addition and subtraction is possible only for the similar surds. What are similar surds? Radicands must be equal and orders must be equal. Okay? And whereas multiplication and division of two or more surds, multiplication of two or more surds is possible only if the orders must be equal. Radicands may be equal, may not be equal. Similarly, like division. Division of two or more surds or two surds, actually two surds is possible if their orders must be equal. Radicands may be equal, may not be equal. Okay? Thank you very much for watching this video. Okay? In the next section, we will discuss how to find square root of a quadratic surds. Thank you very much, okay, for watching this video. Keep subscribing to Praveen Tutorials.